Today is Tuesday, May 12th. Let's go over these problems. They are not in successive order, meaning we're not going to start with Chapter 1 and move towards Chapter 12. These problems will range all over the place. So today's homework, you have 12 problems that you had to do. Let's start with number 1. We see that we have a binomial multiplied times a trinomial. So what we're going to do is we're going to do a double distribution. We're going to distribute this first term into each of the three terms inside of the other trinomial. So let's distribute that. So we'll have 3t times 2t squared plus 3t, it's plus because 3 is positive, times 5t plus 3t times 4. And now we're going to look at the other term in the binomial, which is -2. And we again are going to distribute it to the three terms in the other one. Let's make this a little smaller. Let's group it. Let's make it a little bit smaller so we can get that other work in there. Make my pen a little bit smaller. So we have -2 times 2t squared minus 2 times 5t minus 2 times 4. And now we're going to simplify each product. This is a product, this is a product. We would always do multiplication before addition and subtraction. So 3t times 2t squared, we're going to multiply the coefficients, and then we will multiply like variables. We multiply the coefficients, 3 times 2 is 6. When we multiply like variables, we look at their exponents, and when we multiply like bases, we add their exponents. So t to the first times t to the second equals t to the third. And then we'll repeat it for each product. So 3 times 5 is 15. T to the first times t to the first is t to the second. We have 3 times 4, which is 12. And then we have our variable t by itself. We have -2 times 2, which is -4t squared. -2 times 5 is -10t. And then we have -2 times 4, which is -8. Now, we have done all of the multiplication. Now, this consists of addition and subtraction, and we're going to combine like terms. So we have to find like terms. Like terms have two things in common. They have the same variable to the same exponent. So is there another term here that has a t to the third? No. So it doesn't have a like pair or a common term. So we're going to just write that. And now we look at our next variable, or our next term, which is t squared. Is there another t to the second? Yes, there is. And when we do that, we're going to combine their coefficients, add and subtract. So +15, -4 gives me +11t squared. So we keep the variable after we add and subtract like terms. And now we move on to the next one. We see we have t to the first. So we're going to take their coefficients, 12 and -10, which makes +2t, and then -8 doesn't have a like term. So that would be your solution. 6t to the third plus 11t squared plus 2t minus 8. And this needs to be in standard form, meaning descending order, alphabetical, and then if they tie with the variable, we put them in descending order with the largest exponent first. And so we see we have t to the third, t to the second, t to the first, and then no variable, a constant. Your answer must be exactly like that. Number 2, now we jump into radicals. So we cannot. Here's something that's important to understand. If we have 16t squared, we can separate this into two terms. Whenever a term is multiplied under a radical, we can separate it. If we had x squared plus y squared, we cannot separate this. This does not equal this. You cannot. The only way that we can take the square root or square root cancels is when it's a term, a perfect square by itself. So we look at this and we go, oh, I can't separate this. But hopefully your eye saw that this is a binomial square. We see that it is three terms. Binomial square, remember what the characteristics of a binomial square. Binomial square has four things. One, three terms. Second sign positive. The first and third are perfect squares. And the middle is equal to 2 times the square root of the first times the square root of the third. Times the square root of the third. So, does it have three terms? Yes, three terms. Is second sign positive? Yes, it is. Is the first and the third, are the first and the third perfect squares? Yes, they are. And now, does the middle equal the square root of this times the square root of the third multiplied and then doubled? Do those equal the same? Yes, they do. So if that's the case, then we know that this is a binomial square. So that's going to become that. And now we have the square root of something being squared. So my answer is going to be x plus 5. Not bad. Good one. Number 3, here we have multiplication. And we also have exponents. So we have to be careful about what order we're going to do all of this work. Remember, we have to do order of operations. Order of operations starts with grouping symbols, then exponents, then multiplication and division, and then addition and subtraction. So we're going to do grouping symbols. Yes, these are parentheses, and they are grouping symbols. However, there's no operation inside. So those are not acting as grouping symbols at the moment. They're just acting as, well, they are grouping in the sense of that exponent has to be distributed to each of those, but there's nothing that we can simplify inside. So we're going to do our exponent. Whenever we have the product, we can always distribute. So if we have something like this, we can distribute into parentheses that have multiplication. So yes, that equals 4 to the third times x to the third. However, if we had 4 plus x to the third, we cannot distribute. That does not equal, no. You cannot distribute exponents into addition and subtraction. So we will distribute this. That's 4 to the third. That's x. When we take a power of a power, we're going to multiply their exponents. That's y to the first times third. And now we have an invisible negative 1 here. So we have to have negative 1 that gets distributed to the 2. X to the fifth times 2. And then we have y to the first times 2. So 4 to the third, x to the sixth, y to the third. We have negative 1 to the second. Remember, we're multiplying. We have x to the 5 times 2 is 10. Y to the 1 times 2 is 2. So 4 to the third. 4 to the third, we know, is equal to 4 times 4 times 4, which is 16 times 4, which might be 64 maybe. Let's check it out. Equals 64. Good. So this is 64 x to the sixth, y to the third times negative 1 to the second is positive 1. Remember, that's going to equal negative 1 times negative 1. The negative is included in there. So that equals 1 x to the 10th y to the second. So now we have to multiply like terms. So we're going to multiply their coefficients. 64 times 1 is 64. We have like variables. When we multiply like variables with the same base, we add their exponents. So that's 6 plus 10, and then we have y to the 3 plus 2. So my final answer for this problem is 64 x to the 16th y to the 5th. So here we have the square root of 2,601. I have no idea whether that's a perfect square. I could use my calculator, but what I'm really going to do is I'm going to look to find and break it into two numbers. I'm going to look for factors of 2601. Well, I'm thinking of what factors? Well, remember, I'm looking for perfect squares. I want one of these to be a perfect square. So my perfect squares are 4, 9, 16, 25, 36, those numbers. And I'm going to look primarily into these smaller ones. So 9, does 9 go into 2601? Well, what's the divisibility rule for 9? 9 is add up the digits, and is that sum divisible by 9? So 2 plus 6 is 8, plus 1 is 9. So I know that 9 goes into 2601. So 9 goes into 2601. Oh, that didn't work. 2601 divided by 9 gives me 289. 289. So square root of 9 is 3. 289. And now I'm going to repeat the technique. I'm going to look at 289. What is 289? Is there a perfect square in here that gives me a factor? So I'm going to try 4. 4 doesn't go into numbers that end in odd numbers. Does 9 go into it? So I'm going to try the 9 rule again. 2 plus 8 is 10, plus 9 is 19. 9 does not go into 19, so 9 does not go into 289. 16, well, it won't go into 16 because if it didn't go into 4, 16 won't go into it. 25, no, because it doesn't end in a 5 or a 0. 36, well, that's 6. Do I know? Let's try 36. 289 divided by 36. Probably not, because it's an even number. I think that would be my reasoning here. Let's try 49. 289 divided by 49. Nope. 64, no. What's this? 2, 3, 4, 5, 6, 7, 8, 9 would be 81, no. 100, no. 11. Wow, 289, that's a weird one. I gotta assume that there's something coming though. Oh, 289, let's try 289. 28, nope, that's not 2. 289 divided by 11, I think that might work. Nope, close. 13, 289 divided by 13. 13, nope. not 14, 15, 16. 289 divided, I don't think 16. Nope. 289, 17. Ooh, I like 17. 17, I know some fact. Oh, 17. 17 squared. I will tell you that I know most perfect squares. I did not know that 17 times 17 is 289. That one's going into the memory bank. So this is a perfect square also. So the square root of 289 is 17, and then 3 times 17 gives me 51. So technically 2601 is a perfect square. It is 51 times 51. And you could have put that in your calculator, 2601, and then take the square root, and yes, it gives you 51. But we also like to have a process, and it's supposed to make it quicker, but just a little fun here. All right, here we have two terms, and we have to add them together. We see that they have unlike denominators, so we have to find a common denominator, much like if we were adding 1/7 plus 2/5. We can't add these fractions together until they have a common denominator. An easy way of finding a common denominator is take both of those denominators and multiply them. 7 times 5 is 35. And then we would find equivalent fractions to that common denominator. 7 times what is 35? Well, 5, because I just found that. So we now have an equivalency. These are equivalent. They're the same fraction. They just have a different facade. And then we would find an equivalency of 2/5 is equal to how many 35ths? 5 times 7. 2 times 7 is 14. And now that we have common denominators, we can combine those numerators. So that's what we're doing. Just because we have variables, oh baby, look at that. What happened there? Just because we have variables doesn't make it that much harder. So let's look here. Our denominators are b plus 1 and b. Remember, we can't separate addition and subtraction here, so we have to take that as 1. So the common denominator is going to be b times the quantity b plus 1. That would be the common multiple. We're looking for multiples. They share no term in common, so we have to circle both of them. All right, so now let's find equivalencies. b minus 3 over b plus 1 equals what over b times the quantity b plus 1? Well, what do we multiply this to get that? Well, we're missing a b. So what I do in the numerator, I have to do to the denominator. So my new denominator is b times the quantity b minus 3. Let's look at the other fraction. We have 8 over b equals. So what did we multiply this to get that? Well, we're missing a b plus 1. So that numerator is not going to be plus, it's going to be minus. We see that minus there. And we have 8 times b plus 1. Now, let's simplify. We have like denominators. These are the same, so now we can combine. That was bad. I want to include that negative. So if we put them all in the same numerator, we have b times the quantity b minus 3 minus 8 times the quantity b plus 1 over b times the quantity b plus 1. That is that common denominator. Let's move you guys over. Now let's simplify that numerator. We're going to multiply b times b and b times negative 3. b times b is b squared minus 3b. And now we're going to distribute the negative 8 to the b and the positive 1. Negative 8b minus 8 all over b times the quantity b plus 1. We can simplify. We have two like terms here. B squared minus 11b minus 8 over b times the quantity b plus 1. So we want to see, is that factorable? Can we factor the top? We would do a times c. A is 1, c is negative 8. Are there factors of negative 8? 1 and 8, 2 and 4. The signs are different, and the bigger's negative. Either of those my middle? Nope. So this is simplified to the best of our ability at the moment. That's a good one. Those are, and look, this is the tail end of Algebra 1 and the beginning of Algebra 2. You will definitely begin your Algebra 2 with introduction to this. This isn't necessarily something you will see in Algebra 1. This is more of an Algebra 2 problem. So just keep that in mind, that this is at the edges of that difference between Algebra 1 and Algebra 2. All right, here we have some more radicals that we're going to simplify. We could simplify within this fraction first, but I like 48. I'm comfortable with 48. 147 is definitely an interesting number. We see 7 goes into it. So 48. So I like 4. So I'm going to break that into rad 4, rad 12. I see that 7 goes into this, so I'm going to do rad 7, rad 21. Now, look, 7 and 21 are not perfect squares. All right, so we have to be careful of that. So I do see, let's look at the top. So we have rad 4. So rad 4 is going to turn to 2. And rad 12 I can break into rad 4, rad 3. And rad 7 and rad 21, neither are perfect squares, but I know rad 21 is rad 7 times rad 3. So when we have identical radicals, it's going to pop out. So that 7 pops out, and then I have a rad 3 over rad 3, so those are going to cancel. And then I have this rad 4, so that's 2 times 2. So my answer is going to be 4/7. It's a nice way. I like that one. It's a good one. Rad 180. So I'm looking for perfect squares within there. So I know 9 is a factor of 180, and that's going to give me 20. So I get 3 rad 20. That's going to be rad 4, rad 5. Rad 4 is 2. So 3 times 2 is 6. And rad 5 can't be simplified. We can always simplify things outside of the radical, and we can combine things inside the radical. Number 8. So the first thing I'm going to do is I'm going to separate each, that looked like a 5, sorry, s to the second and t to the 5th. So 144 is 12. It's a perfect square. S squared is a perfect squared also. That one comes out. And there's a couple ways. We can either divide by 2 and keep the remainder in, or we can break these into perfect squares. So t squared, and rad t. That's that leftover that I was talking about. So we have 12s times t times rad t. And my final answer is going to be 12st squared times rad t. Remember, when these have to be alphabetical order, so make sure that that's in order and your radical stays inside the house there. Number 9, 175. Well, I know that 25 goes into 175. How many quarters is $1.75? Well, that's 7 quarters. All right, if I had $1.75, how many quarters would I have? Well, $1 is 4 quarters, and 75 cents would be 3, so 4 and 3 makes 7. So the square root of 25 is a perfect square, and I get 5 rad 7. Okay, let's do this. Let's separate each one again. We have rad x to the 7th, rad x. So I see that rad 36 is a perfect square. That's 6. Rad 25 is a perfect square. That's 5. And now I want to break this up. So I'm going to do something a little bit more advanced here. I'm going to break up x to the 7th to x to the 6th and x. The reason being is I have rad x over rad x. That cancels to make 1. And then I have the square root of x to the 6th. Remember, I said that it's like dividing by 2. So that would give me x to the 3rd. And the reason being is rad x to the 6 would be written as x squared times x squared times x squared. And each x squared would get separated, and the square root of x squared produces an x. So we have x to the 3rd. That's how I did it. And it's a nice little shortcut. It's like dividing by 2. If it's square root. If you have a cube root, you're dividing by 3. If you have the 4th root, you're dividing by 4. Well, here's our first word problem. Alice is 3 times as old as Archie. So if Archie is R years old, then Alice, we'll use an L. We can't use A because Archie and Alice both start. So if Archie is R years old, then Alice is going to be 3 times that. And we think about it. If Archie is 6, then Alice would be 6 times 3. So if Archie is R, if we replace his value, his age 6, we would have R times 3. So that's a nice way of thinking about how to write that properly. If Archie's present age is X, represent each person's age 7 years from now. So Archie is actually X. Whew. All right. So if Archie is X, so sorry, that's not, see, they're not being very nice. Well, let's do this. R equals 3L. So if they wanted in L, or Archie's age, if Archie is X, sorry, that's X, then she's going to be 3 times X, right? If this is Archie is X, and we want to find out how old Alice is is 3 times her age, his age, then it's 3x. That's kind of looks a little weird. It can't be, that's a bad, Mr. Mac did not explain that well. So Archie, and look at the mistake Mr. Mac made. Mr. Mac just read the first sentence and then tried to write something, thinking that he knew how to do it. It's always best to read the whole entire problem first before doing what he tells his students not to do. Don't rush into a problem. That was bad, Mr. Mac. Read the whole problem, and then you might have a better perspective on it. So Archie is X, and Alice is 3 times as old as Archie. So Alice equals 3x. Much easier, Mr. Mac. Archie is X, and Alice is 3 times Archie's age, so Alice is 3x. Represent each person's age 3 years from now. So this is now, and in 7 years, Archie, if he's X, in 7 years, he will be X plus 7. Alice will be Archie's age 3 times. Oh, right, not right now. That's going to be in 3 years. If Alice is 3x right now, she will be 3x plus 7. You do not have parentheses. If that's her age right now, how old will she be in 7 years? You're going to just add 7 years. Ooh, Mr. Mac made that much harder than it needed to be. Sorry about that. The width of a rectangle is 24. Notice I'm going to read the whole problem before I start drawing stuff. The width of a rectangle is 24 centimeters less than the length. The perimeter is less than 172 centimeters. Find the maximum dimensions of the rectangle if each dimension in centimeters is an integer. Ooh, I like that. All right, so let's draw a rectangle. This is the length, and we'll name this the width. The width of the rectangles is 24 centimeters less than, so we're going to have something longer than it is wider. And if the length is L, then the width is going to be 24 centimeters less than the length. So that's L minus 24. So now we have a length of L and a width of L minus 24. The perimeter, so we know the perimeter is the distance around an object. So if we add up each of the widths and each of the lengths, what would we get? So if we add the length plus the width plus the other length plus the other width, that must be less than 172 centimeters. So can we simplify that left side? So let's combine like terms. We have L plus L plus L plus L. So that's 4 L's. And then we have negative 24 and negative 24. So that's negative 48 is less than 172. So let's solve it. Let's isolate the variable. We're going to get rid of things being added and subtracted first. We have to get rid of that negative 48. So we have to add 48 to both sides. That leaves me with 4L is less than, we have 172 and 48, which gives me 220, I think it is. That's 8, that's 12, carry the 1, yep. And now let's divide by 4. So we are left with L is less than, if I do it on my handy dandy notebook, right? 220 divided by 4 gives me 55. So it has to be less than 55 centimeters. So it can't be equal. It doesn't say equal, right? Is less than 172. So when we solved it, my length must be less than 55. And they want an integer as my answer, meaning a whole number. So if it has to be less than 55, what's the next integer less than 55? Well, it would be 54 centimeters. So my length must be 54 centimeters. So my length equals 54. What would my width be? Well, my width would be 54 minus 24, or 30 centimeters. And we have to include the units because they notated it. So my length is 54 centimeters. My width is going to be 30 centimeters. Now, remember, my width has to be 24 less. Is my width 24 centimeters than my length? 54 minus 24 gives me 30. Yes, good. And now let's calculate, and we're checking, let's calculate what the perimeter would be. That would give me 54 plus 30 plus 54 plus 30 perimeter. That's the distance around. So if I add those together, 54 plus 30 plus 54 plus 30 gives me a total of 168. So is that less than 172 centimeters? Yeah, it's 168. What if I used 55? Let's look at that. And what if I had used originally, because it said, right, length has to be less than 55. What if I used 55 as my length? So if 55 equaled my length, what would my width have to be? Remember, it has to be 24 centimeters less. So 55 minus 24 would give me 31 as a width. So what would the perimeter be here in this scenario? So we have 55 plus 31 plus 55 plus 31. 55 plus 31 plus 55 plus 31 gives me 172. But is it less than it? No, it is not. So my length cannot be 55, which would also make my width 31. You say, hey, Mr. Mack, why don't you just make the width 30? Well, because it has to be 24 centimeters less than the length. So it has a contingency. So my answer, it says find the maximum dimensions of the rectangle. So the dimensions is not just going to be 54. My answer would be 54 centimeters by 30 centimeters. That would satisfy all of the criteria. That would make its perimeter less than 172, and it would give a width that is 24 centimeters less than the length. Hope that helps.